We live in a microbial world. Every day, we're exposed to billions of invading bacteria and other microscopic creatures. But after years of trying to exterminate or exclude them, scientists now realize many of them are allies, not enemies. Some are so essential to us, we should consider them as a vital human organ. Scientists argue that instead of waging a war on bugs, in many cases, we should welcome the microbe invasion. For 3.5 billion years, Earth has been ruled by bacteria. They have colonized every corner of the planet and its occupants. As far as they and other microscopic creatures are concerned, the human body is simply another virgin territory to invade and occupy.
We have emerged as a species on a planet that's predominated by microbes. Microbes have learned over the course of millions of years of very stringent selection how to insinuate themselves onto and into their mammalian partners.
So far, we've treated microbes more like enemies than partners, defending ourselves against attack with antibiotics and vaccines. But in the war against disease, scientists are discovering many bacteria actually fight on our side. By studying their strategies and weapons, we can learn from our microscopic allies.
They should be viewed as our teachers. They have been forced to devise a whole range of means of manipulating the biology of their hosts in a way that benefit the microbes, but do not harm their hosts.
For every microbug that causes disease, there are hundreds more that do no harm at all. Some are even our best line of defense against death and disease. Scientists now believe that by understanding the complex partnership between our bodies and their billions of microbes, we may be better equipped to fight deadly infections.
They have developed strategies for manipulating our genes, and by turning to them, we should be able to forge new ways of manipulating our biology to promote health and to prevent disease.
Just like the Earth itself, our body is a living planet, a network of ecosystems where bacteria are the dominant life form. There's only one time in our lives when it isn't so. While it's in the womb, this baby lives in a sterile cocoon, protected from an invading army of bacteria and other bugs. For Sarah Trigoning, this is her 4th baby, but it's still a miraculous and slightly scary experience. This is the moment everyone has been waiting for. The baby, his mother, his father, and the combined forces of the microbe invasion. The first offensive takes place in the birth canal. For generations, occupying armies of bacteria have lived on Sarah, and now they're ready to invade this new world in all its terrain. As the baby emerges from the womb and begins to slide past the birth canal walls, The first tiny microbes leave his mother and attach to the baby's skin. The invasion has begun. Billions of microbial competitors join in. They land, dig in, and secure a beachhead wherever they can. While some of these invaders are our enemies, many will become our closest allies. At this vulnerable stage of life, a baby needs all the protection he can get. Dangerous microbes could win the battle for territory and take his life within a matter of hours. But even as this child takes his first breath, a second invasion has begun. This second wave of microbes launches itself as soon as the baby emerges. Hundreds of competing species race to take up a strategic position on the baby's body. Some are potentially harmful. All of them are common in every mother's intestines.
It's a wee boy! It's a wee boy!
Most bugs will be marooned on the baby's skin and die there. But some will make it into his mouth and be swallowed. Eventually, they'll occupy his intestines.
You got a grandson? And his name is Alexander Charles.
Oh, it's not nice.
Wait till you look at Chris.
If he doesn't pick them up at birth, there'll be plenty more chances in the days and weeks after. Touching, kissing, and even spitting on him. Everyone he meets will cover him in bugs. But these bacteria are a precious gift, an army that will defend this baby throughout his life. Bugs like lactobacilli secrete acid onto our inner surfaces, which discourages other, more harmful bacteria from settling there. Bifidobacteria are another ally. Inside the baby's intestines, they reproduce quickly and protect him from bad bacteria simply by overcrowding them. So it's actually a good idea to welcome some of these microscopic invaders. Scientists believe our body may even encourage bacteria with nutrient signposts just before or after birth.
These signposts consist of nutrients. Nutrients that are manufactured by the cells that line our intestine. Now, an early colonizing species of microorganism is able to use these signposts to set up shop in a particular location of the intestine. It can use these nutrients as important food sources.
Breastfeeding positively encourages helpful bacteria. Mother's milk contains antibodies that specifically target harmful microbes. But it allows helpful species like bifidobacteria to thrive. It's a telling example of our close partnership with many types of bacteria. As Sarah's child grows, all of his available territory, inside and out, will be conquered by microbes. By the age of 2, he'll be occupied by many different species of bacteria. He will never be alone. In fact, like all of us, his cells will be vastly outnumbered by the microbes.
The total number of microbes that colonize our surfaces exceed the total number of cells in our body by at least a factor of 10. So we're more microbial than we are Homo sapiens.
Our entire lives are spent in partnership with friendly bacteria. They have evolved so closely with us that we can even consider them a part of our own family. But other microbes aren't so committed to that relationship. There are plenty of opportunists out there, ready to take what they can from us and move on. Whether we live or die matters little to them. So we and our microbial allies have evolved some sophisticated weapons to protect our vulnerable territory. The mouth is an open door to microscopic opportunists. Every day, we and our microbial partners have to guard against disease-causing organisms like Salmonella that enter here. The constant supply of food, warmth, and moisture make our mouth an ideal home for billions of microbes. Swarms of bacteria like spirochetes live in this rich sea of saliva. And so do their giant predators. Protozoans like Trichomonas prey on them, as well as dead skin cells and scraps of food. When human populations boom in a confined area, they create elaborate structures in societies we call cities. The same thing happens in our mouth, only it's called a biofilm. Using our teeth as foundations, streptococcal bacteria stick themselves to the enamel surface. They and billions of others build blocks and towers as busy and crowded as any modern metropolis. The longer it grows, the more complex life in the biofilm becomes. But just like any human city, these dense populations can produce pollution. Some bacteria create the sulfur compounds responsible for bad breath. Others feed on sugars and excrete acid powerful enough to strip the enamel off our teeth. There's a good reason why brushing and flossing stops these bugs from damaging our teeth and gums. The action tears down the protective biofilm and lets in fresh air. Many of the bacteria living in here are anaerobic. For them, oxygen is a lethal poison. As the biofilm collapses, so does their world. While streptococci are the dominant bacteria in this oral society, they come in many species, most of them friendly.
In your mouth, you have massive populations of these friendly streptococci that are not there to harm us. In fact, they're our closest friends. They're our own, if you like, personal army of protectors, there to defend us against the occasional rogue streptococcus.
Professor John Tagg knows all about rogue strep. As a child, he was plagued with streptococcal infections that gave him sore throats and rheumatic fever, a disease that kills 500,000 people every year. John Tagg survived, but it left him with a burning ambition.
I was quite determined then to get one back on the streptococcus. It became a lifetime obsession.
It took 30 years of research, but Professor Tagg of New Zealand's Otago University has made a major discovery. Not only are some strains of strep harmless, at least one produces its own natural antibiotic, known as Bliss.
Bliss is the little term that we've developed, if you like, for this smart weaponry that bacteria seem universally to apply to deal with the competitors that they will encounter in nature.
The good strep use bliss to sabotage the growth of their competitors. Bliss are chemical weapons that target rival groups of fast-growing strep bacteria. These micro-missiles penetrate the surface of the enemy's cells, allowing vital nutrients to leak out. And so, an entire community of competitors starves to death. By understanding how this biological control system works, the Bliss research team are developing a natural alternative to antibiotics. Trials so far suggest that giving children helpful strep in a tablet establishes populations of these good bacteria in the mouth. The good bugs then go into battle to keep the bad bugs under control. As a result, the chances of getting strep infections are significantly reduced. As Dr. Tagg sees it, it's smarter and more economical to adopt nature's sophisticated weaponry instead of blasting the body with broad-spectrum antibiotics.
Bliss are the equivalent of the laser-guided weaponry being developed today to take out specific targets, rather than the somewhat more crude approach of dropping an atomic bomb and taking out all the terrain and as well as the inhabitants.
Working with friendly bugs to discourage certain harmful microbes in the mouth and throat is a clever idea. Meanwhile, other microorganisms are swallowed and find themselves on a one-way trip through the human gut. The digestive system offers a rich array of habitats for good bugs and bad. This is where we and our microbial partners work hard to keep treacherous opportunists under control. The first line of defense is the stomach. This half-gallon pool of enzymes and hydrochloric acid is enough to tear most microbes to pieces. But it's not foolproof. For years, scientists assumed that the stomach was sterile, but they have now discovered that some bacteria actually make their home in this liquid hellhole. Helicobacter pylori live in the stomach lining. They create their own chemical shield to protect themselves from stomach acid.
Helicobacter pylori is a spiral-shaped bacterium that sets up shop in half the humans that live on our planet. For most humans, this organism colonizes the intestine, produces a short-term inflammation of the lining of the intestine, but then enjoys a relatively, or we think, a relatively innocent relationship with its host.
But for 20% of people with this bacteria, the benign relationship turns nasty. The immune system tries to attack these spiral-shaped bugs. Instead of killing the bacteria, however, the powerful chemicals damage the stomach lining, causing painful ulcers. Other microbes can make it past the stomach safely, provided they know a trick or two. Salmonella is the most common food poisoning bug. It often crops up in badly prepared meat or dairy products. These foods contain fat globules that offer bacteria a protective coating against stomach acids. And so, Salmonella slip past our defenses in a kind of Trojan horse made of grease. But the body does have a means of fighting back against these aggressive marauders. Bile is like dishwashing liquid. It breaks up fat into tinier globules we can absorb. It also happens to be lethal to many kinds of bacteria. However, some microbes survive these perils in protective coats or spores. They head for the small intestine, a rich feeding ground for friendly microbes and opportunists. But bacteria have a hard time settling down here. They must fight against the churning rapids of liquidized food and digestive juices. Any creature that wants to stick around here has to be specially equipped. The only ones that are real monsters. Tapeworms are the ultimate parasites, superbly adapted for life in the human gut. Some species grow to almost 15 feet long. Others can reach more than 30 feet. Such monsters can block the intestine or consume so much food their hosts suffer malnutrition. They reproduce by detaching egg sacs that pass through the intestine to be picked up by another unsuspecting host. These parasites feed while latched onto the intestinal lining with a bunch of hooks and suckers attached to their ugly heads. Most bacteria get swept harmlessly downstream along with the food. But one tough customer will always cause havoc, given half a chance. Clostridium enters the gut in its own protective spore. Once activated, it becomes a protein feeder. It digests the meat in the diet, but it can also make a meal of our intestinal lining. Victims can end up with deadly abdominal infections. To stop these bacteria and their toxic waste products damaging our tissues, every week or two, we shed the layer of cells that lines our intestine.
These cells sit at the interface between a toxic wasteland and the rest of the body. And their renewal probably is part of an ancient mechanism designed to take away damaged cells as a result of their exposure to the toxins that exist in the diet.
The shed cells make a feast for bacteria like Clostridium, and they're welcome to it. But down at the bottom of our intestinal folds, budding young cells are vulnerable to attack. Recently, scientists discovered the powerful defense system that protects them. Paneth cells are like anti-aircraft batteries. They launch packets of destructive enzymes that protect the cell nursery from bacterial attack. For microbes that have survived this far, the hazardous journey is almost over. After traveling 20 feet through the small intestine, they're about to reach the promised land, the colon. This is where bacterial numbers explode and where the partnership between our bodies and our bacteria truly flourishes. We rely so heavily on our friendly bugs that many scientists now consider them as vital as any human organ.
We have 1.5 kilograms of bacteria in our guts which constitute an organ that is as important to our physiology as our lungs or our kidneys or our liver. And this organ does things like helping us to digest food. It provides a lot of vitamins. It breaks down a lot of drugs. It provides various essential lipids and precursor molecules. So it is very much a part of our physiology. We are partly bacterial.
What we choose to consume affects our health. But just as important, is the mounting recognition that our health also depends on the colonies of bacteria that live in our intestines. From her teenage years, Sarah Trigoning suffered terrible digestive problems. She had flatulence, bloating, and stomach cramps.
Sometimes I'd be constipated, and other times I just would be, having dreadful, dreadful diarrhoea. And I had no idea when that would be or what foods would set me off.
Sarah was put on high-fiber diets and treated with steroids, but nothing really worked. Eventually, she was diagnosed with irritable bowel syndrome, a chronic illness that affects up to 25% of the population, mostly women.
When I first started working, I had problems with irritable bowel syndrome, and it was really difficult because I was working in the food industry, and you can't just keep running off to the toilet every 2 minutes when you desperately need to go, and there's nothing you can do to control it. I got to a stage where I was so thin because of the constant diarrhoea and the constant pain in my stomach was preventing me from eating, because anything I ate, anything of a mild nature, would still upset my stomach.
The causes of irritable bowel syndrome are not clear, but most of the symptoms are associated with the colon. We might not think of our colon as the land of milk and honey, but for trillions of bacteria, this is heaven. And it's here that science is uncovering an extraordinary relationship between humans and microbes. This is where the bacterial population explodes, fueled by fiber. Our bacterial allies break down what's left of our food, the roughage we can't digest. In the process, they create waste products, mainly in the form of gas. The gas may be a discomfort, but it's a fair trade for the extra nutrients we get from the bacterial activity. All in all, it makes for a mutually beneficial relationship.
We've come to an arrangement with our gut flora, and we provide a home for them. We provide a surface for them to live on, the mucosal surface, and they provide the nutrient and they provide the protection.
In such ideal conditions, everyone jostles for a prime position. The good bacteria expand quickly to fill the space available. Fortunately for us, that helps keep harmful bugs away from our colon walls.
So our normal bacterial flora provide a really major barrier to any new organisms that want to come and live in our gut, and that particularly applies, of course, to food poisoning organisms like salmonella and things that might sort of wander down there. They're the first defense, in a way, against invading species.
To protect their patch, friendly bacteria like lactobacilli produce acid that discourages harmful microbes from breeding. As bad bacteria reproduce and grow, they often give themselves away by broadcasting toxins into the area. Our friendly bugs listen for such enemy broadcasts, as well as communicating among themselves.
One thing that's becoming quite clear is that there is a lot of molecular chattering going on, not only between the bacteria themselves, but also between the bacteria and our own cells.
This constant chit-chat gives bacteria a good idea of their own numbers and the number of possible enemies, too. If our bacterial allies decide there are too many bad bugs in the neighborhood, they'll attack them with their own biochemical weapons. But the body's defense force, the immune system, is listening in too. If it detects a mounting threat of insurrection, it's always ready to enforce the peace. But when there are too many bad bugs, the immune system just evacuates the area. We experience this as vomiting or a bad case of the runs.
It just throws everything out the nearest way. If the damage has been done in the stomach, then up it comes. If it's being done in the colon, down it goes. If it's in between, it can go both ways.
But there is a drawback to this drastic evacuation. Our empty spaces become ripe for colonization by harmful species. The same thing can happen after taking antibiotics.
Broad-spectrum antibiotics affect the normal, healthy flora of the bowel. And a not infrequent problem in people taking antibiotics is, of course, they develop diarrhea because some of the good bacteria die off and the bad ones start to grow up and produce toxins.
Luckily, we can repopulate our intestines with good bacteria from the supermarket shelf. Yogurt and other live bacterial products, known as probiotics, are proving to be life-changing health supplements. After 15 years of chronic pain and discomfort, Sarah Tregoning chanced upon a solution to her problems. One day, she walked into a health food store and got talking to natural therapist Georgie Chisholm. The therapist recommended Sarah take a daily dose of live bacteria. She thought these good bugs might just help. Sarah was ready to try anything, even swallowing capsules of live bacteria. After 3 months, Sarah's irritable bowel settled down.
I don't have the constant urge to go to the toilet. I don't have the dreadful bloating or the stomach cramps, and I can eat not quite whatever I fancy, but certainly I can eat with a lot more comfort than I used to. It is a miracle cure, and it's literally cleaning me up from the inside out.
Probiotics. The idea that taking live bacteria might be beneficial to human health is only now beginning to gather scientific support.
The scientific community was very sceptical about this at first. The major claims for the benefits of probiotics, I think, are really that they stimulate the immune system, and secondly, that they strengthen this barrier resistance to invading bacteria, and therefore they would help to protect you against food poisoning, infectious diarrheas, or help to improve your gut after you'd had an episode.
But it now seems scientific evidence and backing for probiotics is taking off. When Russian cosmonauts developed digestive problems during long missions in space, medical staff developed a special yogurt to settle their stomachs. They cultured bacteria from the intestines of crew members who were doing fine and fed it to the troubled cosmonauts. By eating yogurt containing their comrades' bacteria, the cosmonauts' troubled digestions were happily fixed.
Taken from the cosmonaut intestine. Cultura. It's culture at its highest level.
What to do with astronauts' intestinal bacteria is an issue that's troubled NASA since the 60s. It's a matter of volume and weight.
There are trillions of bacteria in our colon. And when we defecate each day, half the mass of our stool are live bacteria that emanate from this microbial society.
The last thing NASA wanted on their spacecraft were waste units full of live bacteria. So they devised foods intended to shut down the astronauts' gut-dwelling bacteria altogether.
When the Americans wanted to put a man on the moon, they had to get around this problem of defecation. They designed a special diet which was totally residue-free. There was nothing for the gut bacteria to feed on. And so the idea was that the gut bacteria effectively died. They could go for 3 or 4 weeks without defecating. When the time come, it was an agonising experience. But they could go 3 or 4 weeks. They could do a moonshot.
Everything is go here. We're just waiting for the...
But the idea never took off. Astronauts would have nothing to do with the special diet. Without bacteria colonizing our inner space, we'd all be in deep trouble. But if we allow bacteria into our forbidden zones, the consequences can be dire. The outer surface of an adult human offers around 20 square feet of skin. For microbes, there's a wide choice of climates and habitats. With little sweat or other secretions, our legs are like dry deserts. Here, there are about 70,000 microorganisms per square inch. There are even more in the forest of the scalp. But the steamy jungles of the armpits and groin support the densest populations of microbes. Up to 6.5 million bacteria occupy every square inch. With its oily secretions, the face is a microbe paradise. By the end of a typical day, the bacterial population here is exploding well into the millions. Clostridium spores constantly settle on our skin. In the right conditions, they can become flesh eaters. To protect ourselves from these bacterial infestations, we simply move them on. Dead skin cells detach in small clusters, taking any hitchhikers with them. If bad bugs do get in, they can inflict terrible damage. Mark Ingalls is one of New Zealand's most successful winemakers, but it wasn't his first career choice. He used to be a mountaineer until he lost both legs at the age of 22. While climbing Mount Cook, New Zealand's highest mountain, Mark and a fellow mountaineer became trapped by bad weather. It was 14 days before they could be rescued. They were lucky to be alive, but by then, frostbite had set into their feet.
I always remember on the way to hospital, Phil and I in the ambulance discussing that we'd perhaps lose a big toe. You know, at the worst, we'd lose perhaps all of our toes, but you know, there's plenty of climbers around with missing toes. We didn't even consider the thought of gangrene or the extent of the frostbite and losing whole legs.
In the hospital, Mark's feet were slowly thawed out, but the damage was done.
Every day in hospital, the feet initially swelled up and then started to discolour.
Frostbite had turned the water in his body's cells to ice, rupturing the cell walls and killing the tissue. The destruction opened the way for bacterial infection by Enterobacter, causing gangrene.
With the wet gangrene, they puffed right up, first one foot, then the other, and then after treatment with antibiotics, the foot almost mummified.
In the end, surgeons had no choice but to amputate. On Christmas Eve 1982, Mark Ingalls had both legs removed, just below the knee.
Nothing can ever prepare you to waking up and seeing the sheets end so much shorter on your bed. Those were the worst 3 days of my life.
Keeping bacteria out of the body's forbidden zones requires constant vigilance. Dead or damaged tissue is just one way in for rogue bacteria. But the body has other access points that it must defend. The eyes and ears are protected by a powerful antibacterial compound called lysozyme. Earwax collects trespassers like flypaper, and then lysozyme molecules home in on their captive targets. These antibacterial molecules attack by chopping bits out of the invader's cell walls. Airborne microbes like Clostridium are trapped and killed here every day. But there are billions more floating in the air. And so we have a series of clever traps for dealing with them. In the nostrils, giant hairs and sticky surfaces catch some invaders. But others manage to slip past these defenses. If a dangerous intruder like a Clostridium spore infiltrates the lungs, then bodyguards called macrophages arrive swiftly to deal with them. The macrophage engulfs the invader and removes it for disposal. Millions of tiny hairs on the walls of our airways carry unwelcome bugs back up towards the throat. Once there, we either drop them into the acid bath of our stomach by swallowing, or eject the bugs back into the air with a cough. Every minute of the day, these traps prevent microbes from invading our forbidden zones. At the same time, in places where they're welcome, we tolerate our microbes as part of a healthy ecosystem. But what happens to microbes when we die? The latest scientific research reveals there is indeed life after death. There is one final journey that we and our microbes will take together. The journey to death and beyond. When we die, our bodies are prepared for burial or cremation. While such respect is quite natural, it interferes with the processes of nature. In this unusual outdoor laboratory, people have donated their bodies so that forensic scientists can uncover the secrets of natural decomposition.
Fixed lividity at this point in time, pulling of the
Dr.
blood.
Richard Jans and his team of anthropologists from the University of Tennessee study the process of decay to help criminal investigators identify the time and cause of death.
Bacterial proliferation in the body is pretty active and a lot of bacteria grow, so they're working from the inside out. And then with the warmer weather, the flies become more active and lay eggs, so you'll have a larger maggot population, and they work from the outside in. So, and they're efficient soft tissue carnivores. So it'll go relatively quickly, 3.5, 4 weeks.
While insects play their part in dismantling the body, the forensic scientists are uncovering the hidden role performed by microbes.
Even in the absence of insects, a body will putrefy and eventually decompose. So the decomposition process sort of starts from the inside and works its way out when the body's own microbes consume it, so to speak.
Some of our decomposers may even be descendants of the bacteria our mothers handed down to us at birth. Many of them have helped keep us alive and healthy since the day we were born. Now, without the living ecosystem we provide, they face the end too. As the skin cools and dries out, it becomes an inhospitable place for most bacteria. While the body is alive, the soldiers of the immune system fight to keep rogues like Clostridium out of sensitive areas. But now the immune system is out of action. Without macrophages to keep them under control, vast numbers of Clostridium spores hatch out and rampage through the body. Caught up in a feeding frenzy, the expanding population's activity raises the temperature to over 120 degrees Fahrenheit. As the Last Supper continues, the feasting hordes create large amounts of gas. With all the exits closed, it has nowhere to go. The body begins to bloat as the bacterial party goes out of control. But the contents of the intestine are soon used up.
There are some bacteria which just live off carbohydrate and fibre, and that's it. They don't have anything to eat. They're done for.
Starving and overwhelmed by the protein eaters, our allies begin to die.
There are other bacteria which can digest protein very happily, and they'll start digesting you.
Clostridium and other decomposers finally serve as our undertakers, breaking down our organs and tissues. As they see us into our afterlife, they're also planning their own. Clostridium produces spores for when the party ends. In these time capsules, they can travel freely and reactivate centuries later. About 5 to 10 days after death, the skin bursts. In a flash, billions of partying microbes die when they are suddenly exposed to oxygen and cold temperatures. Those that have prepared for this moment will escape on a breeze, or perhaps on the body of a feeding insect. The rest will die and break down as our flesh dries out and is eaten by scavengers. Only the skeleton will endure, and will be alone for the first time since we left the womb. For most of our lives, we'll be unaware of our body's inhabitants and the battles they fight for us. Good or bad, they can't live without us, and we'd be in trouble without many of them. From the moment we're born, our good bugs will dig in and become our first line of defense.
We acquire these partners from the beginning of our life. As we enter this world, we live with them and we die with them. And the question that I think is so exciting is to decipher the significance of this microbial partnership to our own biology, how microbes shape and participate in shaping our physiology, and how that contributes to our health, and how that sets us up for vulnerabilities or resistances to a variety of different diseases.
No matter where life takes us, we'll never be alone. we'll always be accompanied by our microbial allies, the armies of the Microbe Invasion.
Microbial from Homo sapiens.